Today, we're going to discuss Go packages and modules, including giving you an example of how to use multiple modules in a single repository. Okay, so let's get started with packages. So, what is a Go package? Here's a simple diagram I'll be referring to, but basically a Go package is a collection of Go source files in the same directory that are compiled together. And when we're talking about Go source files, they can contain functions, types, variables, etc. Basically, packages is the main way to organize your code in a Go project, as well as to provide a way to share this code between different parts of your program. So by convention, the package name is the same as the last element in the import path. So let's talk about this example. So we're talking about this package. Here we go. And so this package is going to be in our package1 directory. And then in there, it can contain some Go files, file1.go, file2.go. And by convention, the name of this package, so at the top of this file1.go file, you'll say package_1 by convention. Now, if you have a main package, if you need a main package where your program starts executing, then of course you'll name the package main. But typically, the directory name and the package name are the same. So when the application is compiled, it compiles all the packages imported by the main package. So it's possible that the main package is up here, package1. It only imports like this package. So these two will be compiled together, and then this one's there for whatever reason. This also means that you can compile each packages independently. So you can compile package2 independently, you can compile package4 independently, and most often when this happens is when you're doing unit testing. So you would compile all these independently, and then you can run them in parallel, right? Which is a great feature. So another reason to use packages is so that your unit tests can run in parallel, or you can even spread them out and across multiple machines. All right, so the important point about Go is that this directory structure does not have to match the package dependencies, right? So here, this white line is the directory structure. So at top we have package1. So let's go over to our text example. Oops. Okay, so here we have package1 at the top level, then we have package2 directory, right? And it can have a certain number of files there. Let's do this to mark it as a directory up here, and so forth, right? So these files and this code in package2 can be completely independent of this code and this package up here, right? They don't need to have any relation to each other. Of course, typically you would, put together your directory so that they are related, but there's no requirement that they're related, right? The Go's package dependency graph has no relation to directory structure. All right, let's move on to a module. So what's a module? So in this picture over here, we have module A, and it is basically a collection of packages. That's all it is. A module is a collection of packages. It's also a way to distribute this collection of packages. But like I mentioned before, these packages themselves can be completely independent of each other. They don't have to have any dependency or relation to each other. Of course, most often they do, but they don't. You can also have a nested module, right? So in this directory structure, we have another directory called package3, right? package 3, and in there we actually have another module. So there's a go mod file there. I missed the go mod file up here. There should be a go mod file up here. And this will be treated as its own separate module, right? And we'll see an example of how this works shortly. So let's go ahead and do the example where we're going to have multiple modules in one Go work area. So I already have a directory here. I have my terminal here. So let's go ahead and do go mod init, and then we'll name our modules. And this is an example. I'm going to go ahead and upload this to GitHub. So it's going to be github.com, username project, go modules. And then we see up here a go mod file was created. And let's create a simple hello world file. Let's call it main go. Go modules, is this right? Go dash modules. Can we do a dash here just for experimenting? See, a dash doesn't work. But actually this is going to be a main package anyway, so it doesn't really matter. And we'll do this, our standard hello world. Yep. This is good for an example, right? So we got standard hello world. We can run this. All works beautifully. Next thing is we're going to create a subdirectory. So basically, you do a merge adder from the terminal, cd there, and we're going to do another go mod init. Go mod init, github.com, go modules, get Victor, go modules adder. Now this path is here. It's also kind of a convention, but basically this is where this module is going to be. It's going to be in GitHub under my username, under this project, and in this directory, right? So that's what's going on there. So we got a second module there, and in this module we're going to create a new file called adder.go. Call it package adder by convention, and then we're just gonna add two integers together. Let's see if there we go. Great. Okay, so now what if we want to use this adder package in our main package? What if we want to say here format print line add, there we go. Can we do this? Let's see if we can run this. It's interesting that this JetBrains IDE doesn't throw any errors, right? But when we try to compile it, we can't compile it because this is in a different module. And because it's in a different module, it's treated completely differently. Like this module does not see this nested module. I mean, submodule, we can use that name, but it's not quite true, right? Because these modules are completely independent, right? So one way to do this is like the message says, if we already publish this module, if I check this into GitHub, I can do go get blah, blah, blah. And then I can do this import like this, because this needs to be in my go mod file. Okay, so, but that's kind of inconvenient. I have to check in the code before I can use it. That's just silly. And in this case, we're explicitly trying to use two modules. So we want a better flow. So in Go 118, the idea of workspaces was introduced, which use a new file called go.work. So let's go ahead and see how that works. It's actually pretty straightforward. We go up to our top directory and we say, there is an init step. I'm not sure if it's needed, so let's try this. Go work use -r for recursive. So we want to include all the modules, and dot. Let's see what happens. Okay, it tells me to run go work init first. Okay, go work init. This should create an empty go work file. Okay, and then I do go work use -r dot. So this, there we go. So it's going to use two modules here. This dot means the top module, right? The same location where go work is present. So this module up here. And then this adder means the module inside the adder directory. So once I did this, now if we go up here and we try to compile and run this, it now works. Prints 3. Okay, what else do we need to know here? Well, you might be wondering, okay, so I've got this main package, this module. Can I have a main package in this other module and use it? So let's go ahead and try it. So let's create a new directory. We'll just call it main. And in there, we'll create a new file called main.go. And there, we're going to call it package main. And then we're just going to do the main method. And we're going to use our adder. This is going to be in our adder submodule, adder package. There we go. And will this work now if we run this? Okay, this works, right? So the question is, should you use multiple Go modules in one repository? It's possible, certainly, but generally it is not recommended because fundamentally the package is the compilation unit. So the package is all you need in a Go project to organize your code and, decouple different parts of code from each other via packages. But there are a few use cases where you might want to do this. One use case is where this module B is actually coming in from another repo, some public repo that has this module, and there's a bug or feature you need. So you go ahead and you actually just git clone this, right? You create a new directory. You go here, you just run git clone, right? My dependency, whatever, github.com, yada, yada. It'll create a new directory for this module. And then that code is in your repository. And then with that Go work file, you can use the local code, right? So you might want to do that if you're making a bug fix or adding a new feature, or in some cases, if that other directory project was abandoned, you completely pull it into your repository, right? And it basically is kind of seamless. You just git clone it. Another reason you might want to do this is if you're kind of working in the library and you're like releasing these modules, like you want to do a release of this module independent of this release module, and these modules are kind of related, so you want to work on all of them together, but your consumers of your libraries may only be consuming module B and they never consume module A. So that's another reason. But generally, one project, one module. That's it for today.